With these next few problems, we're going to look at solving systems of inequalities. As you see, we have the two inequalities, so we do have a system. But what we're going to do is every one of these, we're going to look at graphing. So I'm going to do a sketch of every one of these using the graphing skills that we've talked about in class, and then we'll use and utilize the calculator in class as well. So what we have is we'll have our XY plane, and our goal is to put every inequality in slope-intercept form. Y-intercept form and slope-intercept form are the same thing. You basically want to solve for Y. So we're going to solve for Y, which these are, and we want to always be mindful of the inequality symbols. Is it going to be a solid line? Is it going to be a dotted line? So if you've got a less than, then you know it's going to be dotted line. If you have a less than or equal to, then we know it's going to be a solid line. So here I'm going to go down to -2, and I'm just going to add some more tick marks here. So I'm going to go down to -2, put my y-intercept, and then I know it's a negative slope, so I can decrease 1 and increase 1, or I can increase 1 and decrease 1. So what I have is a solid line and I want to shade everything less than. So I want all ordered pairs that are smaller than this line, less than. I also have a solid line, and so I want to go to +2. Go to +2, and I want a slope of -5. So I'm going to decrease 5, 1, 2, 3, 4, 5, and increase 1. So here's my intercept at 2, 1, 2, 3, 4, 5. I've got a solid line between those points there. Okay. And then I want everything greater than or equal to. So I'm going to use a green color, and I want everything greater than, so it's going to be everything this way. And then you're looking at where they overlap. And so I'm going to come back in blue and show that that is the shaded region where there is overlap. What does that mean? That means that any ordered pair that you choose in that region, any ordered pair that you choose in that region will make either this inequality or this inequality true. So let's look at a second one. Both of them are in slope-intercept form, except that this top one, there is no y equal, so it's just x. So we know we're going to have a vertical line. So where is my vertical line? Well, it's at -3. So over at -3, is it solid or dotted? It is a solid line at x equal -3. And then what does that mean? What do I want? Well, I want everything less than that. Okay, so I want all values to the left of that line. So everything to the left of this line makes this inequality true. Now I want to graph this one. So I'm going to go to 2 on the y-intercept, and I want to plot the slope, increase 5, 1, 2, 3, 4, 5, and increase 3. So here's my ordered pair here. Or I could go down 5, decrease 5, 1, 2, 3, 4, 5, and decrease 3. And this would be a dotted line. And that's kind of, let me change that. I need dotted line here. And I want everything less than this line. So I want everything less than this line, and I'm looking for where they overlap. And they actually overlap. Remember, this line keeps get real close to it. So we see that there's an overlap right here in this region. Again, that any ordered pair in this region satisfies this inequality and this inequality. Okay. So, looking at our next system of inequalities, I notice this one is a y equal. So what we will have is a horizontal line at y equals -2. So at y equals -2, we will have solid or dotted. It would be a dotted line. And I want everything greater than that. Okay, so I want all values that are larger than that dotted line. Okay. And then I want to graph this inequality. It is not in slope-intercept form, so I want to solve that for y. So y is less than, and I'm going to subtract the 4x. So I get -4x plus 2. So I want to go to +2, place my intercept, and then I want to apply the slope, which would be decrease 4, 1, 2, 3, 4, and increase 1. So, or I could increase 4, 1, 2, 3, 4, and decrease 1. This would be another dotted line. And I want everything less than. So I'll go with, just go with black here. And so I want everything less than that line. And as you see, where I am now doesn't incorporate the red. So where is the overlap? It's in this region right here. So every ordered pair in this region every ordered pair in the blue region satisfies this inequality and this inequality. Again, now we have both are not in slope-intercept form. So I want to solve both of them for y. So I'll take the top equation, which is 2y is greater than, I'm going to subtract the 3x, and then I want to divide everything by 2. So I get y is greater than or equal to negative 3 halves x minus 1. Since I was dividing by a positive, I don't have to worry with reversing the inequality sign. So I want to graph that one in just a moment. And then here, I want to solve this one for y. So I'm going to subtract the x. So divide by 2. So my other equation would be y is less than or equal to negative 1/2 x plus 1. I want to graph these two. All right, so the top equation, we're going to go to negative 1. So we're going to go to negative 1 and apply a negative 3/2 slope. So we're going to go down 3, increase or decrease 3, 1, 2, 3, and increase 2. That would be a negative 3 to positive 2 slope. And then I can do it the other way. I can increase 3 and decrease 2. Now that is a dotted or solid. That would be a solid line. So I want a solid line to go through these. And then I want everything greater than. So I want everything to be greater than that. So I'll use red. So all the values greater than this line satisfy this equation. And then now I want to plot this one. So I want to go to positive 1, which would be right here. And I want to apply the slope of decrease 1, increase 2, or increase 1, decrease 2. And that will also be a solid line. And I want everything less than. So pick a different color. I'll go with green. And I want everything less than this line. And then wherever you see overlap, that's where the solutions lie that satisfy both equations. So I'll come back in blue here, and we're looking at everything in this region. Every ordered pair in the blue region satisfy both inequalities. Just means that any ordered pair you pick here, if you substitute an x and a y in, you get a true statement. And any ordered pair that you substitute for x and y here, you get a true statement. So let's go to the next one. And I have less than or equal to and less than. So that tells me this one's going to be solid line and this will be dotted. And they're both not in slope-intercept form. So this first one, I'm going to solve that. So I'm going to subtract the 2x. And here I've got a negative y, which means I'm going to have to divide by negative 1, which means I'm going to have to invert or reverse the inequality symbol. So that will give me 2x minus 6. So that slope is 2 to 1. So that's something we got to be careful of when we're dividing by a negative with the variable that we want. We've got to switch from whatever the inequality symbol is to the other one. So there's the first one, and then the second one, I want to solve for y, so I'm going to subtract the 2x. So 3y is less than negative 2x minus 12. Divide by 3. And I get y is less than negative 2/3 x, and negative 12 divided by 3 is negative 4. So there's the other equation that we're going to graph. Let's go ahead and we'll make our coordinate plane. And I'm just going to make some tick marks. And let's plot this first one. So I'm going to go down to negative 6. I needed another one. So I'm going to go to negative 6 and plot my intercept, because negative 6 is my y-intercept. And from there, I'm going to plot increase 2, increase 1. Increase 2, increase 1. Increase 2, increase 1. And this equation was greater than or equal to, so therefore we will have a solid line. And it was greater than or equal to. So I want to shade everything greater than, which would be this direction. So we'll shade that in red. All the ordered pairs in the red region satisfy this inequality. Now let's go and plot this one. Well, I need to go to negative 4. So 1, 2, 3, negative 4 is my y-intercept. And then I want to plot the slope negative 2/3. Well, that would be a decrease of 2 and a 1, 2 increase of 3. And then I can go back up here, and that would be an increase of 2 and a decrease of 3. And that one is less than, so we are looking at solid or dotted? Dotted line. So approximately there. And I want everything less than. So I'm going to come with the green. And I want everything less than this line, so you start to see where they overlap and where they do not overlap. So in this region here, everything in this region right here, all the ordered pairs that fall in that region satisfy both inequalities.